In this video, we'll show how we drill using a compact rig for a heat pump system and how our team installs and lowers the geothermal loop. We'll share key tips for building a proper geothermal field and wrap things up at the end. Stay tuned. The customer's property is located near Bila Tserkva, Kyiv region. The site is already developed, so bringing in a large drilling rig was not possible. That's why we used a compact portable drilling rig. Like all our equipment, this rig is engineered to withstand maximum loads within its weight class. The rig is powered by a 3-phase motor that delivers high torque. In sandy soil, the drilling depth can reach 120 meters, about 394 feet. And the rig can be assembled quickly and easily, like Lego. The geology at this site is complex. At a depth of 35 to 40 meters, 115 to 131 feet, we reach granite. To reduce costs, drilling into the rock layer was not performed. As a result, the maximum loop depth is limited to 40 meters, 131 feet. The borehole diameter for heat pump systems is 160 millimeters, about 6.3 inches. Proper spacing between boreholes is critical for efficient geothermal field performance. For every 10 meters of depth, about 33 feet, spacing between loops should increase by 1 meter, about 3.3 feet. For this site, the distance between geothermal boreholes is at least 3 meters, about 10 feet. The geothermal loop is made from 40 millimeters HDPE pipe, about 1.6 inches, with a 2.5 millimeter wall thickness, 0.1 inch, rated for 10 bar, 145 pounds per square inch. Before fusion welding, the pipe must be properly prepared. Remove the outer oxidized layer, clean the surface, and degrease it. Degreasing is done with standard isopropyl alcohol. The pipes are joined using a special Y-shaped 180-degree fitting connected with electrofusion couplings. There is also an option with a U-shaped end fitting. Electrofusion welding provides a highly reliable and durable joint. Once the loop is welded, we use a compressor to perform an air pressure test up to 6 bar, about 87 pounds per square inch, to check for leaks. In this case, the loops are installed manually, without the use of lifting equipment. The relatively shallow boreholes allow the loops to be lowered by hand. To make installation easier, the loop can be filled with water, or a weight can be attached to the end fitting. The loop is lowered together with an additional tremie pipe used to place the grout. Grouting is carried out using a sand-cement mixture. It is critical to avoid air pockets during grouting to ensure proper thermal contact and system efficiency. Once completed, the excess pipe is trimmed and the loop is capped. The next step is connecting the loops to the manifold and tying the system into the house heating circuit. On this project, the average borehole depth was 38 meters, about 125 feet, with 12 boreholes drilled. The total drilling length reached 456 meters, about 1,496 feet. Drilling, fusion welding, installation, and grouting of the loops were completed in just 7 days. If you found this video useful, subscribe to the channel. Just click the subscribe button. We'll continue sharing technical content on drilling and heating systems. You can also find detailed guidance on how to properly size a geothermal loop field and much more on our website. The link is in the description. And now a question for you. Which heating system do you consider the most effective? Air to water, ground source, or another option? Share your answer in the comments.